Hello, welcome back. I'm Chayan Vinayak Goswami, and in this video we are going to understand what are deformers, what is the basic structure for writing a deformer, and to understand that we would write a basic or simple deformer, which is a ripple deformer or the wave deformer, and later on we would add the features to our deformer and we would make our algorithm a little bit more complexer. So let's get started. First, what is a deformer? Deformer is a dependency graph node which takes one or more than one geometry as an input. Apply an algorithm and gives us the result or the output. So as we know that deformer are the dependency graph node, and the way we would write it, the way we would write the code for it will also be very similar to the way we wrote the dependency graph node or the custom nodes. So what is a difference between deformer and writing a custom node or the dependency graph node? So when we write a dependency graph node, empty node is generated and then we add the attributes to it, then we design the circuitry, and then we write an algorithm or the function to perform the calculation for the dependency graph node. So this is the input 2, input 3, and output, right? But when we create the deformer node, it comes with certain predefined inputs, certain functions inside it, function 1, function 2, and an output node. And now we would take a deeper look at those predefined, or the more accurate term is already existing attributes and the functions. So when a deformer node is created, this is the structure of the deformer node. There is an input which is an array of input. It's a complex attribute which would have further sub-attributes. The second one is a weight attribute, which is also an array of attribute. And then there is an envelope, and then there is an output attribute, which is output geom, which stands for output geometry. And I can delete this one, so this is not an attribute. Now we would take a look at what are these array of inputs, and this is one of the important attribute which we are going to use a lot while writing a deformer algorithm. And it also, the deformer node also comes with a predefined compute function. So a compute function would already exist with some instructions, which would further call deform function, which would have certain arguments or parameters, but this would be an empty function. We are going to write this function. In certain cases, we can override the compute function that comes with the deformer to execute certain or specialized operations, but in this example we are not going to use it. Now we would take a look at input attribute. We would dissect it more. So to apply a deformer in Maya, we select certain meshes in the viewport, and then execute a command, mel command, to create a deformer. Or if it is an already existing Maya deformer, we go to the menu and click on a button. And as soon as we select all those meshes and create a deformer, these meshes go inside this attribute, creating an array of the attributes. So in this case, the array of attribute would be of length 3 because we have selected 3 meshes. So if we take a further look on each unit of this attribute, each unit of this array attribute again contains the complex attribute, which is composed of 2 attributes. So there is a complex attribute inside each unit, and what are these 2 blocks, or what are these 2 attributes? So it is composed of, again, group ID and input geom, and we would need this attribute to apply all our deformation algorithm to the meshes. So we would have a couple of set of command to reach to this input geom attribute from this input. So that's the basic structure of a deformer node. And then we can further add the user defined attributes. We can have more attributes which are defined by the user, which is the blend value or anything else. So we have understood the basic structure of a deformer node. Now we would understand the basic structure of the code. And as I said, that the pattern of the code for the deformer node which will be a lot similar to the way we wrote the dependency graph node or the custom node. So we would take a look at the code of our previously written wheel node and what we would need to write a deformer node. So at this point you would have a good idea of what we would need, because we wrote our DG node based on the structure of the mel commands. So the first thing we would need is a creator function. We would need an initialize function. Then we would need initialize plugin and uninitialize plugin to register and deregister the plugin. Plus, we also need a class which would contain a constructor, and in the DG node we wrote a compute function which here would be replaced by deform function, because the dependency graph node itself comes with a compute function which further called deform function. So this is the basic structure of writing a deformer node. So now let's go to Maya and start writing some code and understanding this workflow better.